So here's the periodic table, and it's meant to be similar to the actual periodic table. In what ways is it similar? Well, group 1 are the alkali earth elements, and when they lose electrons to become more stable, they form a +1 ion. Group 2 is alkaline earth, and things in group 2 like magnesium, calcium, barium, when they lose electrons, lose 2 electrons to become more stable. Group 3, same deal. These are going to be fixed charge +3 ions in this exercise, in ionic compounds. So yes, the column number for these three first columns is the charge number, but that is not true here. So here we have transition metals, and for rhomium and jackium, you have to state the charge in the name and then use the stated charge to correctly make the formula. What are the possibilities? The possibilities are 1 through, 7. Like, there's a lot of possibilities. Okay, so over here, the metals are in red. And so these are all metals, and metals lose electrons to form cations. And in a formula, the metal would always be stated on the left. And then we have the nonmetals. So nonmetals are in blue. This periodic table is different from the real one in a couple ways. Well, in a lot of ways. One is hydrogen. There is no nonmetal to the left of this line. And there are no metalloids or semimetals. And on the real periodic table, everything that touches that line except aluminum is a metalloid that we treat like a nonmetal for nomenclature. Okay, so group 8 is just like group 8 on the periodic table. Those are the noble gases. They're not going to participate in bonding. Why? They're stable. But group 7 is a nonmetal that can gain an electron to be like a noble gas, or it can share electrons to be like a noble gas. So the nonmetals can either become anions, or they can share with nonmetals to make covalent compounds, just like in real life. So here we have the element Kitty. Kitty's in group 6. Kitty can gain 2 electrons to become kitide. When nonmetals gain electrons to form an anion, they get the "ide" ending. There are 2 other endings for nonmetals. Nonmetals can end in "ide," and that's with no oxygens. They've just gained electrons. 8 and "ite." And the "ite" is like the 8, but 1 oxygen fewer. So let's talk about the "ites" and the "8s. So down here I have the anchors. These are the line leaders for the things in the column and the head of the family. So here is Tiger, and Tiger is in group 4, and tigerate is TO3 2-. Just like carbonate, we would have to memorize CO3 2-, like we would have to memorize the formula. And then we would know, because silicon is below carbon, silicate is like carbonate, we can get a derivative. We had to memorize, except I don't want you to memorize. You're given this on your table, which I expect you to use. We're told what tigerate is, and then we know that things in a column behave the same. So if I had MiO, same number of oxygen, same charge, that would be myeloate or mylate. Don't worry about the spelling on these. I'm just saying that you're applying the rules correctly. Okay, so things in a column behave the same. Who's the leader of group 4? Tiger. Who's the leader of group 5? Callie. Leader of group 6? Lucy. And leader of group 7? I think it would be too confusing with the O's. That's why I didn't use Oliver. So these O's here, those are oxygen, just like polyatomics. I'm just saying, if you made an 8 or an "ite," how would that be? For oxyanions, 8s and ites, there's some rules, and the 3 rules we're going to use. The first one is that things in a column behave the same. So there is a column trend, and that is, if I know tigerate, I also know the number of oxygens in charge on the ones below it. The next one is, we know that ates and ites are related. An ite is just one oxygen fewer. And so if I was looking for mylite, it would be like mylate, but 2 oxygens and the same charge. Another rule that we have has to do with hydrogen containing. And so there are some hydrogen derivatives. And the hydrogens can be hydrogen ates or hydrogen ites. So if I know tigerate and this charge is not -1, so I can't do this with scampate because I would make a compound. I would still have an ion. I could add a hydrogen to it. The charge is going to change. It's going to go up by 1, but I still have an ion. And so this would be hydrogen tigerate. There's only one of these that could be a dihydrogen something, and that's kaliate. Because the charge is -3, we could add 2 hydrogens and still have an ion. If we added 3 hydrogens, we would have an acid, and those are named differently. So I'm going to use this periodic table to answer questions, and it limits what I can ask. I will tell you on the real exam, I just realized as I was talking to you, I told you these are noble gases, but then I told you that there was Chloe gas. And I put a 2 there, which doesn't make any sense, but it's a question about how many atoms in this many grams. And so I needed something that was diatomic. So I just picked it because it looks like chlorine. Okay, but so there is one other kind of question that I might ask, and that would be about the acids. And I'll talk about them after we do the worksheet. But I want to go ahead and get started on that worksheet. Okay. So the first thing is, I looked at, just like in regular nomenclature, keep in mind, this isn't just meant to thwart cheaters. This is also meant to reinforce learning. And so it gives us a chance to look at the idea of nomenclature using the same rules, just from a little bit different, we're a little off center as we're doing it. So the first thing is, when I look at a compound that I'm going to name, I have to decide, is it ionic or covalent? So I look to the element on the right and see, is that a metal or non-metal? So Br is right here. Okay, so this is barium something. I'm just going to say barium something ide, and I'm not going to state the charge because it has a fixed charge. The charge is +1. And then I look to see what the other thing is. It's Si, and Si is Simba. And so it's barium, the whole element name IUM, because metals typically end in IUM. I don't state the charge in Roman numerals because the charge is +1. And then Simba becomes Symbide or Symbaide, and I don't care which one you choose. But the second one, the nonmetal, is going to get the ide ending because we have a nonmetal that's gained electrons and it has no oxygen, so it's not an ate or an ite. At any point, you can interrupt me or you can save your questions to the end, but if you interrupt in the middle, that is actually probably better. Okay, ROSC3. I find RO, romeomium, and I realize, oh, I'm going to have to state that charge. So it's going to be romeomium charge, and then the anion is going to end in ide because there are no oxygens. Let me find SC, scampide. Because this is in column 7 and needs a -1 charge, needs to gain 1 electron, and because there are 3 of them, This is romium 3 scampite. Okay, the next one is Si2K4. So I'm looking for Si and I'm not finding it. I'm thinking, oh shoot, Sue made another mistake. And I think, oh, wait a minute. What if it's a nonmetal? If Si is a nonmetal, this is a covalent compound, and I'm going to say how many of each kind. Oh, sure enough, Simba. So this is di-Simba. Keep the whole name. I don't do anything with the ending for the first one. Tetra. And then I find the other one is kitty, and kitty needs the ide ending, kitide. Disimba tetrakitide. For this one, I noticed that there's an oxygen, LO3, and so I'm going to need to use the name that would be memorized, but we have on the table. This is leucate. Oh, but leucate is LO4. So because this is a 3 and that's a 4, that tells me I have an ite instead of an 8. So leucite or leucite, however you want to say that. And then for the metal, it's jackium, and jackium is in the unknown zone, so I have to deduce the charge. To deduce the charge, I look at the charge on leucate, which will be the same as the charge on leucite. I see that it's -2, so, oh, is it JU or J? J. And so it's jackium 2, leucite. Question. Okay, LOKO4, same thing. I have a O. I mean, clearly there's something polyatomic going on here. And I don't see KO4 down here. So I think, oh, it's in line with somebody else. Here's Kitty, K. It's below Lucy. So let me find leucate. It's LO4, LuO4 2 minus. And so if I replace the central atom, Lucy, with Kitty, I get KO4 2 minus, and the name changes to kitate. So we could have scampate, but you wrote CaO4 2 minus. Vince, I'm not sure. So scampate and CaO4 2 minus are different things. I think the idea of your question is right, but I'm not quite sure because of that formula. Okay, so, and then I look, what is LO? It's Lola-ium, and it's already a +2, so that makes sense. And I don't state the +2 because it's fixed charge. There's no reason that's a different color. That's just the color I had. Okay, so MOHTO3. A lot of letters, a lot of numbers. When you're doing the exam, there are only 12 questions. Each question's worth 4 points, 60 minutes. So you have a lot of time. So here's what I suggest you do. You really break these down, calmly. Do some deep breathing, you know, have a cat in your lap and a cup of tea, like you're just doing a homework assignment. And then get your answer and look for it in the multiple choice and make sure that you're looking for subtle differences, like whether this is a 3 or a 4, or whether that's a 2 or a 3. And I'd and Ite, they look very similar. So I suggest that as you do the exam, that you do it slowly and calmly, knowing that you have plenty of time. Find your answer, and then once you've got all 12 done, go back and check your answers, just to make sure that you didn't choose an Ite when you meant an Ide, that kind of thing. So what I'm going to do right now is just pull this apart. I know I have MO, and I don't need to try to figure out what the charge is because it's in group 2. And then I have HTO3, and there's 2 of them. They must be 1 minus, because that would make sense. -1 twice and +2, that would work. So I come down here and I find TO3, but it's got a 2 minus charge. And then I realize, hydrogen was added to tigrate. And that's why the charge is -1. That makes sense. This is hydrogen tigrate. So mollium, don't state the charge because it's fixed. Hydrogen, space, tigrate. Okay, so daisium is a +3, and 2 of them make that +6. This must be -6. Let's see. Silicate. Oh, it's not silicate. Sorry, Simba 8. I don't see it here. So let me see where I can find it. Here it is. And it's below Lucy. And so Lucy's the line leader. But it's a little different because even though, so this is -6 and there's 3 of them, it's -2. So that part's right. But there's 1 oxygen fewer. That makes it an Ite. So Symbate would be SiO4, 2 minus. I must have Symbite. There's probably a joke in there somewhere about cats fighting. Daisium Symbite. So I'm looking for B. I can't find it. Oh, it wasn't where I expected. This must be a covalent compound. The first one is not a metal. That's covalent. So I say how many of each kind. And for the first one, I use the element name. And for the second one, I add "ide." For both of them, I'm going to use prefixes because the mono is on the second one. And we do use it on the second one, like carbon monoxide. We do use the mono on the second one. So this is dibu monoketide. Okay, romeomium and Simba. I don't know about the charge in romeomium, but Simba, which becomes Symbide, was a -2. So it's +6 and -6. So it must be romeomium 3, Symbide. The "ide" ending because there are no oxygens. Because it's a transition metal, I have to state the charge. Questions on names from formulas? Yeah, this will be the periodic table on the exam, both the nomenclature exam, which is part 2, the second one, but also we're going to use these for answering empirical formula questions. I spent time yesterday coming up with some numbers, and we'll use those masses, but the process is exactly the same. Okay, we all have a favorite direction. I don't know if that was yours. Now we're going to go the other way. Sodium tigrate. Okay, 8 means I find it on the table or it's a derivative of something on the table. Find barium, it's a +2. You have +2 and -2, they come together in a 1-to-1 ratio. Oops. Sorry. Lolium scampate. Looks like I'm going to need 2 scampates to balance that +2 charge. Try kitty nonabuide. Here's kitty. And here's bu. That's a covalent compound. Try Kitty. Nona is 9, few-eyed. Jackium 3, smoke 8. They can't find smoke 8, but here's smoky. So smoke 8 is like calate. Just replace that central atom, that first letter, or first symbol. So +3, because we were told that, -3, they come together in a 1-to-1 ratio. Jackium 2, smoke 8. So now we're going to have +2, -3. We'll need 3 jackiums and 2 smoke 8s. And now we have Maxium smokeite. So 1 oxygen fewer. +3, -3, they come together in a 1-to-1 ratio. But SMO3 rather than SMO4. Dicali-pentascampide. Two calis and 3 scans. So try. Oh, penta, 5, sorry. 2 cali, 5 scans. Sodium chloride, the ide ending tells me that I'm just adding electrons. There's no oxygens. One, two, three. +2. Let's shoot for 6. Okay, here we have barium calite. So ite is like the 8, but 1 oxygen fewer. This is still +2, and this is still -3, so we still need to shoot for 6. Tobium hydrogen chelate. So +1 -2. I'll need 2 tobiums. It's a lot of letters. Okay, that's all I got.